Hello everyone. So welcome back to my channel. So today we'll learn another method which is called Euler's modified method, and this is also called Runge-Kutta method of order 2. So this is also comes under initial value problem. Now for a better understanding, I'll suggest all of you to kindly uh, go through the Euler's method as well as the Taylor's method so that you can understand Euler's modified method in a very clear way. Now what we do here in the modification of Euler's method, everything is the starting is same, but there is a little bit modification here. So see, every time we are taking in Taylor's also in or in Euler's also a first order differential equation, right? Dy by dx equals to what? F of x comma y. Then what will be our next line? Dy by dy equals to f of x comma y into dx. Okay. So from there we are getting this particular expression dy equals to f of x comma y into dx. Okay, so if you have already gone through the Euler's method, then you'll understand that after this step, we have to integrate both sides between the limit y0 to y1 and x0 to x1 to get a first formula for y1. Now here in modification, what to do? This f of x comma y. So if you remember in Euler's method, in place of f of x comma y, we put what? F of x naught comma y naught, right? F of x naught comma y naught, and this we can easily find from the initial condition given in the question. Okay, x naught and y naught is already provided to us in each and every problem. So from there we can easily find f of x naught comma y naught, and after putting this f of x naught comma y naught in this particular equation 1 and integrating, we get the value of what? Y1, and successively we can find y2 y3, so as much we can need. Okay, now here the thing is that in place of f of x naught comma y naught, we are going to put this particular expression. Okay, f of x naught comma y naught plus f of x1 comma y1 divided by 2, f of x naught comma y naught plus f of x1 comma y1 divided by 2. Now the thing is that is we know or the all the term. So x naught is given in the question, y naught is also given in the question, x1. So we can find x1. The formula is what? It is x naught plus h. What is h? H is step size. Okay. So I have explained clearly in Euler's method what is step size. Kindly go through this so that you have a better understanding. So x1 is also known to us. Now the thing is that y1. So y1 is not given in the question. To find y1, we need the help of Euler's method. So Euler's modified method, the first value, that is y1, that we have to find from Euler's method. Then where is the modification? From the next term, that is from y2, we'll put this one, f of x naught comma y naught plus f of x1 comma y1 divided by 2. Now, is the modification better than Euler's method? Yes, because in Euler's method, if you go through the video, then we did one problem there where the value of x is how much? 0.1, and we have taken the step size as 0.2, 0.02. Then you see that x1, x2, x3, okay, x4, and till x5 we got. That means there are 5 steps. But here, when you do one problem, you'll see it is not like this. It's a little bit different. So the actual thing I'll explain in the problem. So here the step is reduced a little bit, and whatever answer you will get, there is a little bit more accurate than what Euler's method. So basically the thing is that here we have to do a little bit less calculation. Okay. So let us, so what I have written here, initially y1 is computed by or computed from Euler's method, from Euler's method. And what is the formula? I think you still remember y1 equals to, it's y naught plus h into f of x naught comma y naught. Okay, maybe in the formula in place of x, in place of h, we wrote x1 minus x0. So same, x1 minus x0 is also h. So from this particular formula, first we have to find what? Y1. Okay, now what we'll do now in the next part, when we'll find the modified value, the first modified value of y1, okay, is given by, so this one we are not going to write y2, okay. So this is we'll write like this, y1 to the power 1. Okay, so this is just a symbol. It's not that some derivative or like that. Y1 to the power 1. Since it's modified, so we stick to y1 and the power is y1. If we modify it further, then it will be y1 to the power 2, then y1 to the power 3. Okay, so what is the formula? So its first term is y naught plus next h into, now what we wrote, in place of f of x naught comma y naught, we have to replace this f of x naught comma y naught by f of x naught comma y naught plus f of x1 comma y1 whole thing divided by how much? 2. Okay, so formula is a little bit changed. Maybe you'll think that it's a little bit complicated. It's not like that. It's very simple. So in Euler's method problem, we have to find f of x naught comma y naught, and here we have to find f of x1 comma y1. That is also easy in problem I am going to show. So this is the first modified value. Okay, the second modified value, value of y1 to the power 1 is, now the second modified value, how will denote it? Y1 to the power 2. Okay, this is just a symbol. Again I am saying y1 to the power 2. So here what will be the first term? It's again uh, y naught plus, you can take 2 outside, h by 2. First term will be same, f of x naught comma y naught plus, now this term will be f of x1 comma y1 to the power 1. So see, only the change is in the last term, y1 to the power 1. The modified value we are putting here. Okay, now the thing is that how many times you have to modify it. So in example you will get the accurate idea, but here I am telling a little bit. So till how much we have to find, I am writing one more. So you'll see that y1 to the power 1 we are finding, y1 to the power 2 also we get. Now we are finding y1 to the power 3, which is our y naught plus h by 2 f of x naught comma y naught plus f of x1 comma y1 to the power 2, and so on. Okay, and so on. So till how much you have to find. So this is the first modified value, this one is the second modified value, this one is the third modified value. So you'll see that after doing 2-3 steps, two result will be exactly same. Maybe you are not getting here. Suppose the value whatever you get in y1 to the power 2 and whatever you are getting in y1 to the power 3 are same. If both the values are same, then we will stop here and that will be our answer. So that's why in Euler's modification method we need lesser steps. Okay, in the example we are going to show that. So we have a lesser number of steps here. Okay, so it's very simple. Don't worry. So let us go to the problem. Okay, so I've taken one problem like this, dy by dx, then log of x plus y. So this is our f of x comma y here with the conditions. So this is our y naught and this is what, x naught. So I think by this time you know that what is x naught and y naught, because you already know Taylor's series method and Euler's method. In each and every problem we are provided with y naught and x naught. Then we have to find the value of y at which point? At point 2. Now kindly go through the Euler's method once again so that you'll understand. In Euler's method we have taken a step size, right, h. So in the problem we have taken the step size as 0.02. Now to get x equal to to get x equal to 0.2, we have to do so many steps, right? X1 is how much? X naught plus h. So it's how much? 0.02. Like this, if you go, you have to find 10 steps. After that, you'll get that 0.2. So it will be a rigorous method, right? So many values you have to find. But here in Euler's modified method, a little bit of difference is there. So the difference is that, let us go to the formula again, then I'll give you better ideas. You see, here x1 is not changing, right? Here, let us observe it very carefully. You see, here we have x1, right? Here we have x1. Here also we have x1. And then here also we have x1. So whatever number of modification you will write, we are not going to x2. We just only stick to x1. So now, okay. So just recall the last problem. There we have x equal to 0.1 and we have taken h equals to 0.02. Then we are finding x1, which is x naught plus h. Then we are finding x2, which is x1 plus h. Then x3, which is x2 plus h. So we are writing x1, x2, x3 in Euler's formula. You'll see all these values x1, x2, x3. But here in Euler's modification method, every time we are saying x1. Okay, every time we are saying x1. So there is no x2 and x3. So what to do then? So let us try to understand this part. What will they do then? So if our x is 0.2 here, okay, our x is 0.2. So x naught is how much? X naught is, in this particular question, x naught is 0. So what should we take? H. So here H will directly take what is X. So this is H in Euler's modification method. So that every time we are using X and wherever we stop, we'll get for 0.2. Okay, whatever value we'll get for Y, it is directly for 0.2. And where to stop, I said, we'll get repeated value. So in this problem, you'll get it. Try to understand it very carefully. And it's better if you do with me, then the very first problem, every doubt will be clear to all of you. Okay, now let us go to the solution. So here dy by dx is given log of what? X plus y. So our f of x comma y is log x plus y. Okay, and then y naught is how much? 1, and x naught equals to what? 0. To find y at x equals to 0.2. So what I said, the value of x and h is same. So let us take h equals to 0.2. So you remember this, in Euler's method, whatever value of x is given, you just directly take it x. So this is one modification. In Euler's method, it is not like that. We have to take different step size. Okay. Now let us find the value of y1. So from where we will find y1? From Euler's method. Okay. From Euler's method. From Euler's method, y1. So our y1 is y naught plus h into f of x naught comma y naught. So y naught is given, it is 1. H we have taken is 0.2, and f of x naught comma y naught, it will be how much? Log of x plus y, right? So x plus y means x naught plus y naught. So this is equals to 1 plus 0.2, and log of x naught is our 0 and y naught is 1. So what is log 1? You all know that log 1 is how much? Log 1 is 0. So the final value is 1. So we are finding y1 from which value? From Euler's method. Now we'll come to the Euler's modification value. Okay. So now let us come to the modified part. The first modification value, first modified value of y at x1 equals to what? X naught plus h, right? So x naught is 0 and h is 0.2, so it's 0.2. Okay, 0.2. So how we denote them? Y1 to the power 1. So what is the formula? Y naught plus h by 2, then f of x naught comma y naught plus f of x1 comma y1. Okay, so this is the first modified value. So now everything you know here, y naught is given in the question, it is 1. H we have taken 0.2 by 2, and then f of x naught comma y naught. What is f of x naught comma y naught? It is log of x naught plus y naught, and f of x1 plus y1 is log of x1 plus y1. Okay, so let us find the value. So then 0.1. So this is how much? First one is x naught is 0 and y naught is 1, so it's log 1, and then log x1. What is our x1? X1 is 0.2 and y1 is how much? Y1 we have got y1 is 1, so it is log of 1.2. Okay, so it's log of 1.2. So the value of log of 1.2 we can find by using calculator, and after calculating, so your final value will be 1.0079. So this is the first modified value. Okay, first modified value. So let us write down the second modified value. So second modified value, I will write it's y1 to the power 2. Okay, it's y naught plus h by 2. Then first term is as it is, f of x naught comma y naught. The second term we'll write like this, f of x1. See, x1 is same. Then this one will be replaced by this. So here is the change. Okay, there is a change. So again, y naught is 1, h is 0.2 by 2, f of x naught comma y naught is log 1, so it will be 0, and then plus this will be log x1. Our x1 is how much? Our x1 is 0.2 plus y1 to the power 1. So y1 to the power 1 we got 1.0079. Okay, is it all right? So this one is 0, we already got in the previous part, and then f of x1 comma y1 to the power 1. So it is log of, it will be log of x1 plus y1 to the power 1. So x1 is 0.1 and y1 to the power 1 is 1.0079. So again you can try to calculate it, and let us see what value we'll get after calculation. So if you calculate it, you will get 1.0082. Okay, so take the help of calculator. So it is y12. Now the thing is that how many steps we have to do, right? You see, the first value is, our first value is how much? It's 1.0079. Okay, 1.0079. So this is our first value, and the second value is 1.0082. Okay, so it's increased a little bit, but they are not same. So what I said, when you get repeated value, suppose the value of y1 to the power 1 and the value y1 to the power 2 are same, then we'll stop here and that will be the answer. Since it's not stopping here, we are not getting the same value, so let us find one more and see. So we are going to find one more, y1 to the power 3. So the formula is y naught plus h by 2 f of x naught comma y naught plus f of, again it is x1, but it will change. Now it will be y1 to the power 2. Okay, so what will be the next step? It's 1.2 by 2, f of x naught comma y naught is again 0, and this will be our log x1 plus y1 to the power 2. Okay, x1 is 0.2 plus 1.0082. So if you calculate, okay, if you calculate, you'll see that after calculation you'll get a value 1.0082. See, same number, right? So y1 to the power 1 and y1 to the power 2 are exactly same. So now see, if you do the same problem with the Euler's method, at least uh, you have to do 4 or 5 steps now, depending on the step size. But here at third step, we'll get our answer. And then no need to think about the step size also. There we have to take think that what step size we have to take. So uh, since y1 to the power 2 and y1 to the power 3 are same or identical, same. So therefore the value of y is 1.0082 at x equal to how much? 0.2. Okay, so it's very simple. So I'm showing just one problem. You can do whatever problem we did in Taylor series. Maybe in Taylor series we did 2 problems, and in Euler's method 1 problem. So you can do all the problems by this particular method and see is the answer is changing or not. So if the answer is changing, up to what level, what is the error, okay, how much error is, or if the number of steps is less or not. Okay, so I'm just stopping here, because if I do some more problem, I can do some more problem also, but the video will be lengthy. So that's I'll stop here. Then I'll request you, so before going to this particular method, that is Euler's modified method, kindly see Taylor's method and then Euler's method for a better understanding. In my next video, I'll explain what is Runge-Kutta method of order 2. Okay, thank you everyone. Thank you for watching.